NCERT 2.16. This is show that the normal component of electrostatic field has a discontinuity from one side of a charged surface to another. There is a charged surface. Okay. Discontinuity from one side of a charged surface to the other side of the charged surface. इसकी line continuous नहीं है, discontinue है, that we have to prove. And it is given by E2 minus E1. E2 E1 plus से out E2 E1 and prove E2 minus E1 is equal to sigma upon epsilon naught, and n is unit vector normal to the surface and sigma is the surface charge density. We already know sigma is surface charge density, unit vector n is this direction. Correct? And show that just outside a conductor the electric field is this. Okay, this we have already done. जब मैंने आपको पढ़ाया था on a surface there is a charge, and if we take a sheet or we take two surfaces very close to each other such that the charge is on both the sides, then what is the electric field? For one single, for this one here, the electric field is sigma upon 2 epsilon naught. This we have done. The electric field in this direction is E1. This is sigma upon 2 epsilon naught, but its direction is in this direction, so this is minus. Now, how much will be E2 minus E1? What will be the electric field here? Here, this is under effect of this positive charge as well as this positive charge. This positive charge makes an electric field E2. This positive charge makes an electric field, this one, E1. So, how much is the total of the two? And we will find here, it is under effect of E2 and this is in this direction, so we can write it minus E1, minus in this direction. So net electric field is E2 minus E1. And what is the direction? This, whichever is strong one. So this is the direction because it is on this direction. So E2 minus E1, the direction is normal vector. So this is normal vector. And how much it is? The magnitude is sigma upon 2 epsilon naught E2. Sigma upon 2 epsilon naught minus E1. E1 is sigma upon 2 epsilon naught minus sigma upon 2 epsilon naught, and this comes to sigma upon epsilon naught. This, and what is its direction? Normal to this, so we write here normal to this. This is here. When we come here, then it will change, it will become negative, but the magnitude will remain same. So this we had already done. Again we are doing it. Sigma upon epsilon naught is here. Now our question is, see the language of the question. It says, show that normal component of electrostatic field has a discontinuity from one side of a charged surface to another. Discontinuity, yes. Here electric field is negative, 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 positive, positive, positive. What about just at a center? Negative, positive. At the center it has to be 0. After that these charges start electric field on this side. Here these charges start electric field on this side. That means this electric field is present here, present here, present here, but it is not present here. Similarly, this electric field in this direction is present here, 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 but not present here. That means this electric field cease to be here. यहाँ आकर ये खत्म हो जाता है. ये इलेक्ट्रिक फील्ड यहाँ खत्म हो जाता है. तो इस जगह पर इलेक्ट्रिक फील्ड खत्म हो गया, यानी डिसकंटिन्यू हो गया. यहां तक कंटिन्यू, 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 डिसकंटिन्यू, कंटिन्यू, 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 डिसकंटिन्यू. सो जस्ट एट द सेंटर the electric field gets discontinued. This we have shown. Electric field on this side, electric field on this side. So we can write it at a sheet. Okay. Continue towards right on right side, and this is which one? E2. Left on left side, E1. At the point of junction, it is possible, or it has to, one has to discontinue. एक डिसकंटिन्यू होगा तो दूसरा स्टार्ट करेगा. ये एक यहां पर नहीं आया, यहां पर ये दूसरा स्टार्ट हो गया, तो इस लोकेशन पर उसको क्या होना पड़ेगा? इट हैज टू डिसकंटिन्यू. एट द पॉइंट ऑफ जंक्शन it has to discontinue. Therefore this is a discontinuous electric field. Okay, now its second part. In the second part, it is asked, show that the tangential component of the electrostatic field is continuous from one side of a charged surface to another side. Tangential component of the electrostatic field. This is electrostatic field, this is perpendicular component, and this is tangential component. All the charges here are settled. They are not moving. So why they are not moving? There is no force, and force is what? QE. Okay, the charges are moving from higher potential to lower potential, and if the charges are not moving, then how are these potentials? Equal, 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 equal. Charges are in equilibrium. Therefore it is an equipotential surface. Therefore it is an equipotential surface. What they are asking us, show that the tangential component of the electrostatic field is continuous from one side of a charged surface to another. The potential difference is how much in equipotential surface? The potential difference is equal to 0. That is why the charges are not moving. Now if equipotential surface dV is equal to 0, then how much is E? Our answer is E is equal to dV by dr. Therefore, electric field that is along the surface, dV is equal to 0 and dV is equal to work done per unit charge. Therefore, work done is 0. Work done is 0. Now, work done is 0 when it is possible. Work done is 0 is possible when the electric field value remains same. It does not change. From here, E is equal to 0. So if E is equal to 0, then how much is force? 0. If force is 0, then work done is 0. And where is this 0 value? That is along the surface. So along the surface, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That means all along it is 0, whether you go here or here. So if you start from here, 0, 0, 0, 0, 0, 0. कंटिन्यू है कि डिसकंटिन्यू हुआ बीच में? यस, ये कंटिन्यू है. तो इलेक्ट्रिक फील्ड कैसा है? कंटिन्यू. सो वर्क डन इज 0, इलेक्ट्रिक फील्ड इज 0, देयरफॉर इलेक्ट्रिक फील्ड इज कंटिन्यूअस. नो चेंज इन डायरेक्शन. कौन सी डायरेक्शन में? इस डायरेक्शन का नाम है along the surface. Along surface. Along the surface it is 0. Okay, this was 2.16. Now let's go to question number 2.17. Okay, 2.17, a long charged cylinder. This is a cylinder, long charged cylinder, has linear charge density lambda. Per unit length इसमें कितना चार्ज है? आंसर है लैम्डा. देखिए, चार्ज सरफेस पर फैला है, पर दिया क्या है? पर यूनिट लेंथ. नो प्रॉब्लम. इस वन लेंथ को हम लेते हैं, उस लेंथ में जितना एरिया आता है उस पर चार्ज कितना है? लैम्डा. 2 लेंथ लेंगे, 2 लैम्डा, 3 लैम्डा, 4 लैम्डा. सो दिस वी कैन गिव इन द टर्म्स ऑफ सिग्मा as well as in the terms of lambda. So they have given here in the terms of lambda. Okay, it is surrounded by a hollow coaxial conducting cylinder. This is the axis. There is another cylinder which has the same axis and it is coaxial. That means it is this way. This is another cylinder. This is coaxial cylinder. Okay, it has got charges. In this internal one has charge on it, and this charge is per unit length lambda. The question is, what is the electric field in the space between the two cylinders? Between the two cylinders, this is the space. Any location at this space, what is the electric field here? This we are supposed to find out. Nothing else is given. We have to measure, we have to assume that this location is at certain distance. Let this distance be d. Then we would like to find out what is the electric field at this location. To find the electric field, we are using Gauss theorem. और Gauss theorem पढ़ाते समय मैंने आपको बोला था, you will have to use it in the any situation which is given to you. Here is the one situation given to us. We have to find out electric field here. So, what were our 4 steps? Remember that. The first, consider a Gaussian surface, which is a closed surface and which has symmetry of electric field and theta. In this case, you have done it that whenever there is a line distribution of charge, the shape of Gaussian surface is a cylinder. So in a cylinder, the electric field is normal to the surface at every point. Theta and electric field are here. The distance is same, so electric field strength is same. Angle on the surface is always at right angle. With area, it makes 0 degree. So we will start with that. Step number 1, consider a Gaussian surface. Let this point be P. Consider a Gaussian surface passing through P. Consider a Gaussian surface passing through P. It has a cylindrical shape. It has a cylindrical shape, and this is also coaxial. Length L. So यहाँ पर हमने एक सरफेस बनाई, ये ऐसे इतना ही डिस्टेंस इस तरफ लिया, चारों तरफ लिया, और यहाँ पर हमने एक सिलेंडर बना दिया. That cylinder will be like this. This way. Here again. Now, this is curved surface. There are 2 surfaces, top and bottom. They are plane surfaces, and this becomes our Gaussian surface. In this Gaussian surface, what is the direction of electric field? The electric field is always normal to the surface, so this is direction of the electric field. Now, if you consider here, the area vector is here, area vector A, and this is electric field E. They are making angle 0. Here also area vector and electric field make angle 0 for the curved surface. For curved surface, theta A and E is 0. Okay, now what about flat surface? For flat surface, here is the area vector and this is electric field vector. The angle is 90 here, angle is 90 here, angle is 90 here, and angle is 90 here. See? So at every place for the flat surface, the angle between area vector and electric field is 90 degree. We will write it here. For flat surface, at every point theta is 0. Okay, now description is done. We have described what is our Gaussian surface, what is electric field direction, and what is theta. Now we will calculate closed integral EDS. We will divide it into two surfaces. One is curved and other is flats. In flats it is EDS cos 90. So if it is cos 90, in the next step it is going to be 0. Now for curved it is EDS cos 0. Cos 0 is equal to 1. You see, this closed integral is converted into two surfaces integral. So we will not put the sign of closed, we will make it only surfaces. Now for this, at every point E is same. So this we will take out as E, and cos 0 is equal to 1. We have to do only integration of ds. And here this will become 0. So in the next step, closed integral ds of Gaussian surface. This Gaussian surface has got certain length and certain radius. How much is the radius from this place to this place? Is d. So the base circumference is 2 pi d, and this length we have taken as L. We have written it here, the length is L. So how much is the curved surface area? Curved surface area is 2 pi d circumference into height L, this, and then this E is here, plus 0 we need not write. So this becomes closed integral EDS value. Okay, now charge within the surface. देखिए इस गॉसियन सरफेस के अंदर कितना चार्ज है. तो ये चार्ज बाहर है, ये चार्ज बाहर है, ये बाहर है, ये चार्ज गॉसियन सरफेस के अंदर है, ये भी अंदर है, ये भी अंदर है. तो ये कितना? तो आंसर है ये वाली लेंथ है L, कैपिटल L, और एक यूनिट लेंथ में कितना चार्ज है? लैम्डा. लैम्डा इज द चार्ज पर यूनिट लेंथ, और ये लेंथ L है. So the charge within the surface is L into lambda. This is the charge. If we say this charge is Q, then Q value is L into lambda. 1, 2, 3 steps are done, and now we take the fourth step, that is applying Gauss theorem. Okay, applying Gauss theorem. What is Gauss theorem? Closed integral EDS is equal to Q upon epsilon naught. Putting values. Putting values, closed integral EDS, what do we get? E into 2 pi dl is equal to Q upon epsilon naught. Q is equal to L lambda upon epsilon naught. And this gives us L is cancelled from both the sides. E is equal to lambda upon 2 pi d comes here, 2 pi epsilon naught d. This is our expression for electric field here at any point between the two cylinders. Now you see this result is very similar to the line charge. एक लाइन चार्ज के लिए गॉस थ्योरम लगा के आपने निकाला था, यही एक्सप्रेशन आया था. दैट इज करेक्ट, क्योंकि इसके पास जो चार्ज है, दिस चार्ज बिहेव्स एज इफ इट इज lying on the axis, line charge, because it radiates out electric field in the same manner. So this is how we will do it. So this is done. Electric field is so much. Let's go to next question. In a hydrogen atom, the electron and proton are bound at a distance of about 0.53 angstrom. .53 angstrom, 10 to the power minus 10 meter, and here is proton and here is electron. This electron moves around proton this way. Okay, the charge on electron and the charge on proton we know, that is 1.6 into 10 to the power minus 6. Okay, now our questions. Question A, estimate the potential energy of the system. Potential energy of the system in electron volt. In electron volt. Okay. Taking zero of the potential energy at infinite separation from the proton. Okay, that we know at infinity it is zero. If electron is brought to this distance, then what will be the potential energy of the system? Have you done any formula? What formula? There are two charges located at a certain distance. What is the potential energy of the system? You know it very well. Electrical potential energy of the system is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R. Put the values at this and you will get it. 9 into 10 to the power 9 into the charge on proton and charge on electron, 1.6 into 10 to the power minus 9. Both are same, so we will put it square. This is to be divided by R. The distance 0.53. 0.53 SI system, 10 to the power minus 10 meter. Now this is potential energy in SI system. So in SI system the answer will be in joule, but they want us to find out in EV how to convert joule into EV. The answer, yes, we have to divide it with 1.6 into 10 to the power minus 19. Again, remember 1.6 into 10 to the power minus 19 makes 1 electron. So 1.6 into 10 to the power minus 19 coulomb. This is electron volt. This into 1 EV. 1 E into 1 V. 1 E into 1 V. QV. This is 1 electron volt energy. In SI system, 1 E is 1.6 into 10 to the power minus 19 coulomb, and volt is in SI system, so this is 1. This is 1 EV energy. This is making 1.6 into 10 to the power minus 19 into 1 joule. Joule makes 1 EV. Therefore, X joule will make how much? X upon 1.6 into 10 to the power minus 19 EV. So whenever we have to convert joule into EV, what we will do? Divide with 1.6 into 10 to the power minus 19. Let's do that. This is 19. Okay, so this is our potential energy in terms of joule. How to convert it into EV? So divide it with 1.6 into 10 to the power minus 19. And now this joule has become EV. Understand? When we convert joule into EV, divide with 1.6 10 to the power minus 19. Now you know in the next step this minus 19 will come up and become plus 19. That means a very large EV. Yes, because EV is a very small unit. 10 to the power 19 EV is equal to 1 joule. Correct? So this was in joule. To convert it into EV, we divide this with 1.6 into 10 to the power minus 19. And now we can write it EV. Okay? So any joule quantity of the energy divided by this will convert it into EV. ये थंब रूल याद रखिए, इससे डिवाइड करेंगे तो EV बनेगा और इससे मल्टीप्लाई करेंगे तो जूल बनेगा. ठीक. अब एक चीज छोटी सी और देखिए. When we multiply Q1 and Q2, this is positive charge, positive 1.6, and this is negative 1.6. And when you multiply the two, what will be the sign of the result? That will be minus. So this whole thing will be minus. Now you solve this. This comes to 27.2. What is the unit here? Electron volt. What is this? Potential energy of this system. So this is done. Potential energy of the system is 27.2 electron volt. Now part B, it says what is the minimum work required to free the electron given that its kinetic energy in the orbit is half the magnitude of potential energy obtained in this. This electron which is rotating here, it has got some binding energy. What is binding energy? Whenever a charge or whenever a particle has got zero energy, system, zero energy, what is the distance between them? Infinite. When this was at infinite distance, the energy was zero. Okay. When it is here, the energy is not zero. How much is the energy? Let's find out. The total energy of electron. Can I rub it? So I will do part B here. Total mechanical energy with the electron is kinetic energy plus potential energy. How much is the kinetic energy? It is given that kinetic energy is half of the potential energy. This is the potential energy. Potential energy is minus 27. Okay, first kinetic energy, how much? What is this question? What is the minimum work required to free the electron? Okay, so we have to find the total energy. It is given in the question that kinetic energy is half of the potential energy, so we make half of this. This is potential energy and half of this is 13.6. This is kinetic energy. Now what should be its sign? Remember, kinetic energy is never negative. It is always positive. This you have studied in the previous class. According to mathematics, its formula is half mv square, and whether velocity is positive or negative, its square will always make it positive. M is a scalar quantity and m is always positive. So half mv square is always positive, k is always positive. So when it is written in the book that kinetic energy is half of the potential energy, they are talking about the magnitude, not about the sign. So the sign is always positive. And potential energy is negative, 27.2. So how much is the total energy? So the answer is total energy is minus 13.6. This is the total energy. And what is the unit? Electron volt. Now this is the energy with the proton. When we take it to the infinity, what should be its energy? Its energy should be 0. Okay, how can we make this energy 0? Will we have to give energy or will we have to take energy? The answer is we have to give it energy. How much energy? Plus 13.6 we will give it. If we give it energy plus 13.6, what will be total energy? 0. And at 0 energy, what should be the distance between two? Infinite. That shows if we take it to infinite, what does it mean? It will leave the orbiting work and will get free. Will get free from the orbiting job. Why it is doing a orbiting job? Because it has certain loan of energy, negative. इसने ऋण लिया हुआ है. It has taken a loan. It is in deficit of energy. How much? 13.6. If I pay its loan, if I give it energy 13.6, then it become a free electron. Give. So how much energy I should give? 13.6. Then it will become a free electron, and with 0 energy, where it can exist anywhere it likes. It can go to infinity, it will become free. So why it was making an orbit? Because it was having a loan of minus 13.6 negative energy. That is why, because of this negative energy, it was making a orbit. So this energy was responsible for orbiting system. So that is why we call it binding energy. This is the energy which keeps it binding with it. Anyway, binding study is not our topic. Our topic is how much work we should do so that it become a free electron. Answer is 13.6 electron volt we will have to give it. We will have to do. How we give it? We do a work on it. What is the work we do on it? We don't get into detail. Basically, we will give it a push. How much work, how much energy we will give it? 13.6. Then it will fall out of it and go to the infinity. So our answer is 13.6 electron volt work has to be done on it to make it free. Okay, this is our second answer. Is there any other part? Yes, part C. What are the answers A and B above if the zero of potential energy is taken at 1.06 angstrom separation? If this separation becomes 1.06, if this is the separation, then what will be all these answers? Okay, do it again. In this place, what we will put? This 1.06. Then this answer will change. We will make half of it. That will become kinetic energy. Again, do this operation, addition of the two. That will give the work required for it. Okay, so this is the process you should remember, and according to this process, you can find out potential energy. Half of that is kinetic energy, but the sign is plus. The total energy is, again you will find, the total energy is always equal to kinetic energy, but opposite in sign. See, this is plus, this is minus. And this is potential energy. This is a strange relation. This relation you have already done. Remember satellite. Okay, this is a satellite. The same equation you have done there. The potential energy is negative. Kinetic energy is positive, but half of its value. The total energy is negative, and that is known as binding energy. To make it free, that binding energy work has to be done on it. So whatever is the distance, we will calculate for that distance. Okay, now we go to the next one. If one of the two electrons of H2 molecule is removed, we get a hydrogen molecule ion H2. This is one H. This is another H. and there were 2 electrons. One electron is here, other electron is removed. Okay, listen. If one of the 2 electrons of H2 molecule is removed, in the ground state of an H2 plus, the 2 protons are separated by 1.5 angstrom. This 1.5 angstrom. Correct? And the electron is roughly 1 angstrom from each proton. This and this, both are 1 angstrom. Okay, quite possible, don't go on the drawing, there are certain adjustment. This electron is 1 from both. Now, determine potential energy of the system. Specify your choice of the zero of potential energy. Our answer, zero of potential energy for our system is when the electrons are at infinity, because our formula, what formula? Q1 Q2 upon R is derived on the basis that we have brought the charge from infinity. So our reference for zero potential energy is at infinity. Okay, we will simply mention it. Our reference for zero energy is at infinity. That's why we are allowed to use the formula. Which formula? Answer, the potential energy of the system. How many particle system? 3 particle system. And 3 particle system, yes, you remember it, correct. Q1 Q2 R12, Q1 Q3 R13, and Q1 Q2 Q1 Q3 Q2 Q3. This is R23, and all are to be multiplied with 1 upon 4 pi epsilon naught, which we get as common. This was our formula for potential energy of 3 particle system. Now you can put the values here. What are the values? Q1 Q2, here Q1 Q2 Q3, all 3 are E, so we can always put it as E square upon R12. If this is particle 1, this is particle 2, this is particle 3, then how much is 1 2? 1 2 is 1.5 angstrom. 1.5 into 10 to the power minus 10 plus 1 3 1 3. This is E square again. And what is the sign of this? Plus into plus. Plus. What is sign of this? Plus into minus. Remember it, it's very important. Minus. R13 1 3 1 angstrom 1. Again 2 3. This is 2, this is 3, this is plus, this is minus. So this is again minus E square upon, and this distance is again 2 3 2 3 1 angstrom. 1 into 10 to the power minus 10. Okay, now let us solve it. One upon 4 pi epsilon naught, 9 into 10 to the power 9. Yes. Now it has become very easy. What we take out is E square. So 9 into 10 to the power 9 multiplied by common E square 1.6 into 10 to the power minus 19 multiplied by 1.6 into 10 to the power minus 19. This is E square taken out to be divided by this is common taken out. From here what can we take out as common? 10 to the power minus 10. Then what remains inside the bracket? Inside the bracket it is 1 upon 1.5 minus 1 upon 1 minus 1 upon 1. This. Okay, now you can solve it very well and you will get the answer that this energy is equal to, okay, do it. Okay, now you tell me what we are getting here is energy. This energy, what will be its unit? You have taken charge in SI system. What is the proof? Here is the proof. 1.6 10 to the power minus 19 coulomb, SI system. You have taken distance not in angstrom, you have taken it in SI system, meter. So what will be the unit of your energy? SI system, that is joule. But for electronic system we give the answer in electron volt because joule is very large for it. How to convert joule into electron volt? You have just done. We do it by dividing it with 1.6 into 10 to the power minus 19. So if we divide it with this, then what will happen? Earlier it was joule and now this will convert to EV. By writing this we have converted into EV. Okay, now let's do it this way. So our answer will be in EV. Now do the cancellations. This is cancelled, very well, gone. This is minus 1 is minus 2. Minus 2, how we can write minus 2? That is minus 3 upon 1.5. This is minus 2, 1 upon 1.5. Yeah. How much it is? So this will be 1.5, 3 minus 1, that is 2 upon 1.5, and this will be negative. This portion. Now see this portion. 10 to the power minus 10 will become 10 to the power plus 10. It will come up. This will be 19 and this is minus 19. Cancelled. Now what do we have here? 9 into 1.6. This has been cancelled. 9 into 1.6 into this bracket. 9 into 1.6 into this bracket. And when you solve this, okay, this comes to 19.2 electron volt. This is the energy and the sign is negative. Because there is a negative energy, it is an indication that there is a force of attraction between them. Always for the force of attraction the energy will be negative. Okay, so this is our answer for it, energy of the system. Okay.